Everyone joined?
Yeah. Only two are there. If anyone further join, I will tell.
Okay. So, C will answer only?
Yeah.
Okay. So, yeah, means EM means what question they have asked related to EM that I have to clear actually regarding EM. Like last question I asked, I didn't understand that 100-finger devices.
Yeah, can you repeat that question once again?
Okay, so that time, 1 minute. Okay, so 200 milliampere, I think that was, and 1 micrometer. I still maybe some wrong figures, and 100-finger devices that time. I need to calculate. So you
100 finger, right?
yeah, 100-finger, yeah.
Okay. Actually, when we calculate about mass weight, W by L ratio, right? W by L ratio. W means what? 100 fingers, right? We cannot modify.
Yeah.
I will take. Okay, and now they gave 1 micrometer. Basic formula for resistance: R is equal rho L by A. A is equal width into thickness.
Okay.
Thickness we cannot. Width is not in our hands because it is a doping concentration. It depends on the material. So
Okay.
we have only option width. So now I taken R is equal L by width. L is length and W is width. Gate width. Okay, L is the length of the gate. W is gate width. L is length of the gate.
Yeah, that time, yeah. L is gate of the, yeah. Okay.
Okay. Now R is equal L by W. L is 1 micrometer.
Okay.
Micro means 10 power minus 3. Okay.
10 to the
power? Minus 3.
Minus 3, acha, okay.
Okay, 10 power minus 3 by 100.
Okay, so means 1 into 10 to the power minus 3 by 100 finger. Okay.
Okay, now IR. Okay, I we know, right? 200 milliamperes.
Yeah, I we know.
200 into 10 power minus 3.
200 into 10
power minus 3 and 10 power minus 3 by 100.
Yeah, that I'm not getting actually. Like V is equal to IR, okay?
Yeah.
And then
we know I, right? 200 milliamperes.
Yeah, I know. And resistance R, how we will?
R is equal to, I told you formula, L is equal W by L. R is equal to L by W. That is R value.
Yeah, R is equal to L by W, that I got. So then L is
1 micrometer.
It is 1 micrometer, okay. Then W
width is 100 finger.
Yeah, width is 100 finger, okay. 1 and that is 1 to the power 10 to minus 3, okay. Fine. So
by 100, yeah.
By 100, yeah, got it. So here I will again R will put then 10 to the power minus 3 by 100, right?
Yeah, but when we take width, it is in micrometer, right? Micrometer means 10 power minus 6.
Okay. Okay, so yani 100 into 10 to the power minus 6, right?
Yes, exactly. Then 200 into 10 power minus 3. This is I value. V is equal to IR, right? So
Yeah.
now I'm substituting I value 200 in 10 to the power of minus 3 into now I'm taken R value 10 power minus 3 by 100 into 10 power minus 6. The
Yeah.
bottom 10 power minus 6 and top minus 6 will cancel. Okay.
Okay.
Now
Okay.
V is equal to 2 volts.
Okay. 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 Fine. So,
Do you have any doubt?
no, now fine. Like 10 to the power minus 2, that will be cancelled, or yeah, 200. So 200 volt, it's right.
200 volts by 100 fingers.
Okay. All zero divided. Okay. Fine. Yeah. Yeah. Got it.
Top 10 power minus 3 and the bottom 10 power minus 6 cancel and we have 200 by 100 fingers. 2 volts.
10 to the power minus 3, and but still 10 is missing. 10 to the power minus 3 cancel with 10 to the power minus 6 and 10 to the power minus 3, and here 10 to the power 2 only, right?
No. 10 to the power of minus 3 top we have 2 10 power minus 3, right? 10 power minus 3, 10 power minus 3 is 10 power minus 6. And bottom we have 10 power minus 6. So both will cancel. So
Okay,
now
that
we have only 200 by 100.
okay,
So
okay,
the
fine.
bottom 2 zeros and top 2 zeros cancel. Now we have only 2.
2. Okay.
Voltage units, volts, 2 volts.
Okay, okay, fine. Fine, got it. So, like, or what type of question they will ask related to YAM? Like, this is the same, means one question they ask, so means how more question they ask related to that, if you can describe.
Oh yeah. They will ask mostly about EM. What is the EM? How you avoid while doing the layout?
Yeah, mostly asked actually, but last time one guy took my interview and like he's asking that question. Generally, mostly they ask EM only, what and prevention, that's only because layout people don't calculate, I feel so. But I don't know, he asked me, okay, you have to prepare for that, and means actually he offered a job, but he said ki, okay, you have to know that EM calculation, you have to study, and then we will schedule an interview with client actually. So that's why.
Actually, I too don't know how to calculate the EM. So far, I have used EM sheet we have in when you are working. They will give the EM sheet. Just we will give the current value. Automatically in the Excel sheet,
Yeah, in
we know the
technology,
width.
yeah,
That
yeah.
I know, but I don't know how to calculate.
Okay, 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 fine, fine. Okay, got it. Uh,
One question: when you have odd number of devices, how you do the matching for differential pair? For example, A is equal 7 and B is equal 7.
okay, so
So this is the
I
difference.
shared with you that was fine.
Uh, Actually, that is fine, but that is not perfect.
Okay,
That is one of the matching.
yeah, okay.
Yeah.
So what is best for that? A is equal to 7 and B is equal to 7.
But when we have the odd number of devices, we cannot use for common centered matching.
Okay.
I tried here interdigitization matching.
But interdigitation we can go easily actually. So interdigitation we have no issue.
We don't have any problem with odd numbers, right? When we doing
Yeah,
interdigitization matching.
interdigitization, yeah.
Yeah. That time AB.
Actually, I
AB.
asked means same answer I repeated actually in interview. I think they feel satisfied with that answer. I don't know exactly, but I feel like that that is a sufficient answer. Matching
What is the common centroid? Actually, we have to show them mirror image or
mirror
folding, right?
symmetry coincidence.
But
Yeah,
yesterday you gave one matching. That is not foldable. That is not mirror image also.
but we don't have device. Then how we can? Then we have to add devices. Na? It is not. Then it is obviously not
Yeah.
possible if it is odd number of devices.
When we have the odd number of devices, better to use interdigitization.
Okay, okay.
Otherwise, we need to add dummies.
Yeah, dummy is yeah. With
And one
dummies
more
only.
option, we have the 7, A is equal 7 and B is equal 7, right? When we placing in one row, that time it is even. So 14, right? 14 we can place in one row. We have the
Yeah.
when we have the space in X direction. That time only it is possible,
Yeah,
otherwise
got
it is not.
yeah,
Hmm.
yeah, got it.
And moreover, in lower nodes, when we use common centered matching, the routing is difficult to do because the gate, two gates are different and two drains are different, right? At least we need to route 4 metals over the device. So we need to maintain
Yeah,
minimum DRC between either M0 or M1, right?
yeah.
So we cannot give them maximum width. Instead of that, we
Okay.
can use in interdigitization matching, and then we can keep small. Instead of small metals, we can use more width. At least we
But
need
it is
more.
like means it is like depending upon technology, na, right? Okay,
Yes,
this
it is depends on the
like in
technology.
3 nanometer it is not possible because we have very less metals, we have a cut layers we have to use. So in 3 nanometer I
Yes.
feel so it is not possible. So if
We will get
technology,
M0 errors in lower
yeah,
nodes.
M0 errors we will get.
Yeah. When they ask about the matching, first we have to ask to them. It is lower nodes or higher nodes. Once they decide about the nodes, and then we'll use the matching accordingly.
Oh, okay. One more question they ask like means higher nodes we know we need to go for matching or lower nodes we go for means matching. Which one we
Higher
have to?
nodes we go for matching. Lower nodes we are not considering matching.
Okay.
Yeah.
I answer opposite actually that time. Yeah, I feel like
In lower
lower.
nodes, most of the designers they are not required matching
Okay. Yeah, in
because of the
7.
routing difficulties.
Okay. Mm, so higher we need to go for matching. Okay.
Because right, the
Yeah.
P cell height is mostly 180 or 180 180, right? CPO to CPO in lower nodes. So in 180 width, we have to place 2 metals for drain, 2 metals for gate, and 2 metals for source. So I have to route 6 metals in 180 width. If I take common centroid matching, so I'm unable to place 6 metals with possible width. So that's what I haven't used common centered matching in lower nodes.
Okay. Uh, like one more question, like I asked last time with you, like difference between the like means higher nodes and lower nodes.
Difference between higher nodes. Okay.
Yeah.
When we are going to lower nodes, the routing complexity increase and DRC, and the
Okay.
gate length will reduce.
Okay.
Uh, we have the more advantages than higher nodes, but we will get more leakages.
Oh. in lower technology, right? We get more
Yeah, lower
details.
technology. Yeah, because we have to route all the routing on over the devices.
Okay.
So we will get more parasitics.
Okay. And something you told more last time. I feel more people will be joined today, so I think more people will question now.
Yeah.
But I think no one will there. So that two answer only, like we go for like means leakage and parasitic effect we will get.
And the gate length also will reduce.
Okay. Okay. Oh,
1 minute. I'm getting
okay.
call.
Sure.
1
Sure.
minute. Hello. Sorry.
Yeah, right. Yeah, it's okay. No issues.
Actually, in Indian interviews are tough than here. Here the interviews are easy.
Okay, voice is not loud. Can you repeat?
In India, when the Indian guys are coming to interview, they're asking different questions and difficult questions. Yeah.
Okay, okay, maybe.
Mm.
Hmm.
Do you have any other questions?
That few question like now I'm feeling like okay, I'm okay. But some resume review if you can do, then it is also fine for me. Because like in some people like they are telling him this is few less, you didn't work like this is very few. Matlab, they want to add me more project and like I don't want to add more project because they will ask more questions. So I am like quite confused. Ki what should I do? Like I need to more or this means generally I get the interview call, but then
Okay.
like in mid they will say like okay you have very less mention and seriously I very less actually because I done more projects but due to that lack of knowledge I'm not adding more projects in my resume actually.
Okay. Yeah, I will ask few interview questions.
Okay, okay.
What is the difference between analog and digital signal?
Okay,
How you know when you look at the schematic, how you know it is analog or digital?
seriously no idea, no one asked this question actually. Okay, difference between we can know by symmetric.
No.
Seriously, no idea actually. Analog. No, no idea. I need to study this question.
Okay. What is the healing?
What?
Healing. Yield. Healed.
Yield. Okay, so
Mm.
like yield is fabrication process. You're like saying what is yield? So we have
Yeah.
to use DFM actually designed for manufacturability to increase the yield means that productivity like means fabrication like 100 chips is we fabricated then number of chips should be working is like 80% or 90%.
Okay. What is the use of DFM?
DFM.
What is the use of DFM?
DFM we generally use to increase the yield actually.
Okay. Mm. Explain any two DRC.
In 3 nanometer, we have and zero errors. We will get we have to cut. We have to cut them. We have to use cut layer to uh, cut the M0. We don't have means we just use cut layers with M0 metal. So we will get DRC related to that with M0 or enclosure we will get device to devices or OD align. So many errors in DRC.
Okay. What is LVS?
LVS is layout versus schematic. Whatever we design in schematic by layout, whatever we routing we done routing device placement and length width whatever we design so it should be matched with the schematic so to know the so we just to check our semantic and layout should be matched. So that is a check to know our layout is going to work or not.
Okay. In LVS, I have shorts, comparison LVS, and property, and mismatching nets. Which one you have to solve first?
First, I will go for short. Second, I didn't get what to. Can you repeat?
I have shorts, comparison, property error, mismatch nets,
Okay.
and you're gonna fix first.
Okay. 4 only you told, na?
Yeah, 4.
Okay. So first we will go for short. Then we go for mismatch. Then we go for comparison and property. Then
Okay, first shorts, then mismatch.
mismatch. Third comparison. Fourth property.
Okay. What is the cloning?
Cloning is just a copy of layout.
It is the copy of layout. Just
Means
normally also
clone.
we can copy, right? Why we go for cloning? If it is copy of layout.
No idea. Cloning, don't know.
Yeah, cloning is nothing but when we have same devices and same W by L ratio, but
Okay.
different nets means different signals. But one net is going connect to A and other net is going connect to B. Everything is same. Only net connections are different. That time we use cloning.
Okay. Well, repeat once more.
When we have the same devices, same W by L ratio, only the difference is net connections. For example, first device net connected to A and the second device net connected to B. That time we will use cloning.
Okay. Okay. Fine.
And what is the difference between cloning and synchronous copy? Synchronous copy only we will use for routing. Cloning
Okay.
we will use for device.
Okay. Okay. One guy asked me like if we have in a layout, we have two nets we have, okay, and same pin we on that net. So what error we will get?
We have two nets. For
Yeah.
example,
Two.
A1 net and B1 net. And
Yeah.
both the nets connected to same pin.
No, both nets are different, but we have a same pin.
How it will happen? Oh, same pin name.
Yeah, same pin name. Same pin name.
Okay. But it is same pin name. We can short, right?
I don't know. Seriously, I don't know.
Same pin name or either way. Sometimes we are able to see the pins 1 down to 0. That time we have two pins, but the net pin name is different, right? One is, for example, VSS1 and VSS0. But when we take the VSS, it is 1 down to 0. That time we are
We
able to see
will
two
get
pins.
extraction only, right? If we have a same, we will get extraction only, right? It is.
Sometimes it will tell duplicate pins in extraction.
Okay. Okay, fine.
You didn't ask the answer for this question to interviewer
How can I ask for your interview?
after the interview.
I will ask next time. Some interviewers are good actually. Okay, they will like sometimes they just explain, like later they will explain. But you know, na like when they will ask hard question and we will know that result. So like our mode is so off, then we will okay just close the laptop and go.
Okay. What is the antenna and how you resolve that?
Okay, so while fabrication, wherever there is a lengthy metal connected to the gate terminal, so what happened during fabrication? The charge accumulated on this metal plate and can destroy permanently the gate device actually. So that is the antenna effect. It is that problem occur while fabrication actually. So to prevent this, we don't keep long metals. If it is going long metal, then we have to break with jumper. Like we have to go with break that metal with upper metal.
Upper metal means?
Like if we will getting antenna in M1, so we will chop the M1 metal and we will connect routing with M2, M1 to M2, and then again M2 to M1. We will connect the gate.
How you resolve that? If I use jumpers, how it will resolve?
So what happened? Fabrication going layer by layer. So first it will fabricate M1, then it will fabricate M2. So what happened? There is no part to accumulation of charge to gate till with the till the gate actually. So we break the metal, and this is how we prevent.
Still, we have the connection between M1 and M2, right? We cannot
No,
break.
no,
We
no,
have the
no,
VF1.
no. What happened? See, we fabricated M1, right? And then it will fabricate M2.
Mm-hmm.
So M1 will be fabricated, and then charge will be vanished.
How
Before
it will vanish?
before they will do some process. If with every layer they will do this process actually. So charge will be means
Which process?
uh, some that uh, name I didn't remember, but yeah,
Yeah, after fabrication, they will do planarization.
planarization. Yeah.
In planarization, whatever charges are accumulated on the metal, those charges will discharge.
Discharge. Yeah.
Yeah,
So
that's
this is
the planarization process.
planarization process we do.
Yeah, first they will go for M1 fabrication and they will do planarization for M1. All charges are discharged and they will go for VA1 and M2. So
And
while
two.
that
Yeah.
process, while planarization process,
Yeah.
whatever, so it will protect the antenna.
Yeah. This is many more methods to prevent that. Like antenna diode, we can use. Yeah. That only.
Have you placed the antenna diode?
We have an antenna diode we use generally, but I never used actually.
We have to place antenna diode in reverse bias. Why? Because while doing the fabrication, we are using higher amount of temperatures. So when we place diode in reverse bias, because of those temperature, the reverse bias diode will burn out. That's what we are placing the diode in reverse bias. And one more disadvantage when we are placing the diode in forward bias, search for so forward bias diode, the gate will not turn on. That's what we will go for.
Yes. We go for reverse bias.
Yeah.
Irreversible six. And routing will also go complex if we use in forward bias also.
Yeah. And only two options to prevent the antenna. Is there any other process?
One more option like again dummy, we connect with the dummy also, but I think antenna diode is more better than using dummy devices.
I don't have space for antenna diode. How you resolve?
So like metal jumper, we use metal jumper.
I don't
We
have
will,
access for the higher metals.
okay, so now we will use dummy devices we place nearby. So we will go for dummy.
How you use the dummies?
Dummy, what we source or drain terminal of the dummy devices, we will connect near to the what means as much as possible, if as much as possible near to the device, we connect the one or source or drain any terminal, we connect with that gate, that metal gate, while when means in on that metal we will getting antenna, so that metal we will connect with that source or drain terminal.
What about gate? Gate terminal where you connect
Gate dummy only,
for dummy devices?
so dummy we will like we always short, so we can go for, we can connect all three terminals with that device.
You will connect all terminals to the uh, gate terminal. How you
Gate
connect?
will go gate, and I think drain we will short with VSS or VDD, and that one terminal we will short with that gate metal.
Which terminal you have to?
Any source or drain, any we can connect.
But I'm asking about gate terminal. Gate terminal where you need to connect.
Gate terminal is shorted with drain or source, means any of that, and that we will go with tap.
Okay. How it will protect if we connect like that?
Repeat, please.
How it will protect when you connect like that? You are saying the source or drains, one of them
Okay,
connected
so
to
okay, so
supply.
that is a dummy device only. So what happened? Charge first touch with that source or drain terminal, means the device terminal, and the device will go permanently damaged, and our actual device will be prevent.
Okay. In actually the antenna effect when we are getting in layout, actually when I'm working in Intel, I got the antenna effect. I have two fin device in 5 nanometer.
Okay.
Two fin device means my gate length is very smaller. So that time I have got antenna effect. I don't have space for antenna diode. They told me that don't use jumpers. That time I used dummies. So I have used two dummy devices. I have placed one is the right and one is the left for active devices. And
Okay.
all terminals are shorted, source, drain, gate, and the net connected to the gate of the active device. That time my gate area is increased, so it prevents the antenna.
So all three shorted with that gate terminal,
Yes.
means source, drain, gate, all
Yes.
three,
Yeah.
and left and right side you put.
Left and right.
Okay.
Then the gate area is increased right now, so it will protect
And
the antenna.
where you connected that net?
Gate input. Gate terminal. Active device gate terminal.
But then you will get violation, right?
What violation?
Means see, all dummy devices should be shorted with VSS or VDD, right?
No, no need. We didn't get any error. Because why I'm getting antenna effect? My gate area is not sufficient to protect the antenna. That time I got the antenna, right? So
So you did change any schematic or not?
yeah, I changed in schematic.
Yeah, that I want to know because we need to change in schematic.
I
Then
added dummies in schematic. Then all terminals are connected to gate of the active device.
that is perfect answer. Yeah, yeah, yeah. Got it. Got it. That answer.
What is the stack dummy and actual dummy? For example, I have differential pair. I need to
Okay.
add dummies on drain net. How you connect the dummy device in schematic?
Okay. So in 3 nanometer, we will in schematic we need to add, no,
Schematic
right?
is same for all the devices, all the nodes, either lower nodes or higher nodes.
Yeah.
We didn't see much difference in schematic.
Can you repeat your question once again?
I have differential pair.
Okay.
Not differential pair. I have one critical net in schematic.
Okay.
So for that, I need to add one dummy on that net.
Okay.
On critical net.
Okay.
How you add a dummy for that net?
So first we will need to change in schematic.
How you change? How you connect?
Okay. So in 3 nanometer we called we copy the schematic, okay, and edit in local. Then we will send to the schematic designer to add that dummies in the actual schematic, and then they will change, and then again then we will means then we will do the name. I seriously I forgot actually. They called.
No. Actually, I'm asking how you route, how you connect that device to actual net. My
Okay,
question is
so
how you connect it.
okay. So one terminal I will connect with that, and other two terminals we will short with VSS or VDD.
Which terminal you connect to critical net?
Any nearby, like means if it is dummy, then there is no means like source is drain or drain is so that there is no means. So any nearby means if there is if device means on device side we will connect and other two terminals.
No. I'm asking which terminal you will connect to critical net.
Source or drain terminal we will connect with critical net.
Either is fine.
What?
Either nets are fine. Either source or drain. Or which one we need to connect?
In 3 nanometer, we generally share the drain or source means whatever means there is no source or drain na, in dummy only. So any net is we can connect.
Okay. So here we need to connect the drain to the critical net.
Okay, but drain is like how drain is there means like if there is no source then how can drain means in dummy there is no source drain concept, right?
No, we have option source and drain option, right? When we call the PCL to the layout, we are able to see so which one is the source and drain. When we turn on the text layer in the palette, so then we are able to see which one is the source, which one is the drain.
No. I'm just like telling. Okay, so Like in dummy devices, we all need to short, right?
Yeah.
Like
I'm talking
if
about stack
we
dummies,
like if we
normal dummy.
like see suppose we have a device, okay, so if we have to connect in left, then we will connect with drain, and if this that dummy is in right, then we will connect with source, right? Because we can swap na source and drain. It is up to like us na ki what is source or
In
what is
7
drain.
nanometer, yeah, 5 nanometer, we have possibility to swap that, yeah, drain source. I need to connect drain signal to the critical net. That time we have option to swap the source and drain. Then we need to connect drain to the critical net.
No, I'm just telling, like, see, we have a dummy device, okay. So
Okay.
if any two we short, then that like third is whatever drain or source. We in it's a in layout it just calculate a like source or drain because
No,
we
in
know
some
this.
technologies, it is not considering source or drain swapping. We don't have that possibility. So they in Intel 18N,
Okay.
uh, the source and drain is fixed.
Uh,
We cannot swap the source and drain.
okay.
Yeah.
I7 we can swap actually, and 3 also. So I know that only. So
Yeah. Okay.
that I feel okay because
In
there is
other technology, I mean Samsung also we don't have possibility to swap the source and drain. Samsung
okay.
5 and 7.
Then it will gonna tough na to for layout people.
Yeah.
We can save the area because of that only, that swapping technology.
Yes. Yeah.
And
Sometimes
even
it happens.
7 we can flip the device also, like in 3 we can't do, and that's why area will going more. But in 7 like we can flip the device also, so because with there we have a 4 metal layers in M0, so both side it will gonna 5, but in N3 it is 3 only, so we can't flip the device. So we can in whatever they are giving, we have to place in that according to that only.
In 3 nanometer, we have a swapping option. We can swap the source
Swapping,
and
not
drain.
flipping. Means device we
Okay.
can't flip. Yeah, swapping we
Yeah.
can do. Flipping we can't do actually.
Okay. In 3 nanometer, I don't remember that we can.
Mm,
We can flip, right?
No,
Top
in
and
3,
bottom, right?
yeah, we can't flip.
Okay.
We can't. No, we can't flip.
Okay. Okay. What is the well proximity effect?
Okay, so what happened during formation of anvil? We use photoresist marks actually. So due to that marks, the ion implantation, the atoms is scattered from that photoresist marks, and the wedge of anvil, edge of anvil can, the doping concentration can be more or less due to this photoresist marks actually. So whatever the device placed near to the well boundary have a different performance, mostly due to modified VT actually. So the performance may vary plus minus 10%.
Okay. What is the LOD effect?
Uh, Okay, so this is like same like WPE. What happened due to some process variation? Our source and drain area is not going to equal, so we will get stress effect actually. So our OD is going to synchronize, like a source is going synchronize or drain. So due to that imbalance, we will getting the LOD, length of diffusion effect.
How you protect that?
A dummy device we use for both the WPE and LOD.
Okay.
The LOD is fine. That answer is fine.
Yeah, we have one more option. We have to share drain instead of, yeah. We need to add dummies compulsory, and always we used to share drain instead of source.
Okay. No, that
One more
definition.
advanced.
That definition is fine.
Yeah, that is correct. Yeah, fine.
Okay, because I seriously, I feel like no confidence when I'm telling this answer because some guy like, okay, no, like they are telling. So I
Oh,
feel,
okay.
yeah, because I means that in one interview only that answer actually he told me. That time I don't know that LOD. So he
Okay.
told me, okay, this is the reason.
Okay. For the design rules only, we need to add dummies.
At that time, I answered okay. So that uh, due to merging the source or drain, what happens? Source is not going to equal with drain. So then we will get LOD. Actually, that one YouTube channel, he is telling that answer. So I just told him, and he said no, this is not the answer.
Okay, is not satisfying with the LOD answer or WP?
LOD. That time I actually wrong answered actually. Now I answered that only that stress strain effect due to that we will get LOD effect.
Okay. So what is STA?
Shallow trench isolation. Okay. So to prevent leakage, we will dig P near to the if we have a P device and N device. So to separate, we do some isolation technique that is called shallow trench isolation.
Okay. Yeah, I have only those questions. Do you have any other question?
Okay, so I didn't prepare for that. I feel like more people will ask and I will ask some questions. So as of now, I think
Yeah, I asked you one question about ring oscillator.
ring or
Oscillator. I have three inverters. I have to connect in ring manner. So I have to make
okay,
same resistance for all the. For example, I have one inverter,
okay,
three inverters in a line. The first inverter output I have to connect it to second inverter input. Okay, I have to maintain same resistance for all three inverters. Okay, now the output inverter I have to connect the first inverter input. So here I have to make same resistance. So how you connect that?
Hmm, just like parallel, we will do like in parallel connection. We will do with all three inverters.
No, it is not possible. I have to only one connection on metal.
No idea.
Yeah, you note down this question and read and tell.
Okay, once more you can repeat.
Three
Repeat.
inverters. Three
Okay.
inverters. How to connect a ring oscillator.
Okay. Ring oscillator. Okay.
The output of last inverter. How to connect the first inverter input.
Repeat, please.
Output of the last inverter. I have to connect first inverter input.
Okay. Last inverter.
I have
Okay.
to make same resistance for all the nets.
Okay. I've seen all the net. Okay. Fine. Okay. Okay. I will check. So now you're giving any interview? Any interview scheduling?
Last Friday I gave one interview.
Okay. It was fine or
Yeah, it was fine. Today I have second round. Today evening.
okay. Wish you good luck.
That is a small startup company. Yeah.
But it's fine not to getting adjusted because they will work for bigger company only, right? Startup only
Yeah.
also. So it's gonna
Today
good anyhow.
Actually,
We just
technical round is done. Only behavioral round is there.
technical final.
Yeah, technical fine. Yeah, I
Okay,
passed
okay.
that.
Then almost you're gonna get the offer.
Yeah,
Then.
I'm thinking so.
Okay. Great.
I have few more questions. Why we are doing metal orientation?
To prevent cross coupling capacitance, just we do metal orientation.
In layout, how you reduce the capacitance
Um,
while doing the layout?
while doing the layout, like in metals.
Yeah, in metals.
So metals, we have a first wheel M0 is like horizontal, M1 is vertical. So due to that, we are going to protect cross coupling capacitance.
No. I'm asking. We have to follow the orientation. I agree.
Okay.
How you protect the? How you reduce the capacitance while doing the routing?
Okay. Shielding we can do, right?
No.
No, no, sir.
I'm
Okay.
not asking about coupling capacitance. I'm asking about parasitic capacitance.
Uh, parasitic
Coupling
planarization.
capacitance. Coupling capacitance is different, right? Coupling capacitance means when we have the critical signal and noisy signal, we will run side by side, then we will get coupling capacitance.
Okay. Yeah.
Yeah, you note down the question and we will discuss.
Okay. Okay. Fine. Parasitic, na?
Yeah, parasitic capacitance.
Almost this question will be fine from my side. Only in from like these question asked, na sometime random question they ask. Then I will be in trouble actually that time.
Okay.
Uh, I don't know. My luck is not working actually. Seriously, I'm. So I don't
Next
know.
time it will work. Okay. I will
Hope.
take the interviews. Yeah.
Okay. 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 Let's see. Hope for best.
What is the low pass filter and high pass filter? You can note down these two questions. Low
Okay.
pass and high pass filter.
Okay. Fine.
And one more question. Note down I is equal 10 milliampere
Okay.
and D is equal to 1 microampere. Micrometer means it is a D.
V is equal to.
D for donkey.
Okay. D is equal to 1 micrometer.
1 microampere for 1 milliampere for micrometer.
Here for micrometer. Okay.
How to find width? W.
Okay. Fine.
And one more question. I have two blocks. One is the sensitivity block and one is the noisy block.
Okay.
VDD and VSS connected to a noisy subblock, but
Okay.
I have to connect the sensitivity VDD VSS to the noisy block VDD VSS.
Okay.
How you protect that? I don't have any option to connect VDD VSS for sensitive block.
Okay. Fine. Okay.
Yeah. Yeah, that's all I have.
Okay. Sure.
What is the fin? Fin.
Fin,
Fin.
okay. Fin is a channel between the source and drain. So like yeah, that's only. It's channel between the source and drain. So we have a multiple fins we have.
What is the difference between contact and via?
Contact, like in higher technology, with connect with metals, we use contacts actually. And in lower technology, we don't have contacts. We just connect with metal with via. It means, yeah. But in higher technology, we have to connect via contact only.
No, in lower nodes also we have contacts, right? VG and VD, those are the contacts.
No, we have a via only. We don't have contacts in lower node.
What is the VD and VZ?
VD is via.
No, that is the contact.
I feel that is via only.
Via 0 is the via. Why they started via 0? If VG and VD is the vias, if they started via 0, via 1 and via 0 is via 2, right? Why they started via 0? If those are vias.
Okay, so seriously, I feel like that is higher notes. We have a contacts, and that time in like in 180 I worked. So we have a square shape in that oxide diffusion. So that is like contact, and in lower technology I didn't see like that. So I feel like that is via only
No,
because we can.
VG and VD also in a square only, right? Square
But
type,
like
20
see,
cross 20.
like via G and via D. Okay, via means via we can use anywhere. No? Like if we have a three metal, then we can choose according to our metal na, where we need to that place that via. But in contacts like higher technology, that we need to connect with contact only. We can't go for like okay we can't go look okay we need to connect here then we place that via that there. So it is not like that, right?
No, in lower nodes also we have the contacts.
Okay, so okay, I will
Yeah, you
that
can read and we will discuss about it.
okay, contact with. Actually, maybe by shape I confused actually because in higher nodes we have a square shape with when where we can connect with higher metal.
Here also we have square.
No, we can in 7 also
Depends
we
on
do.
the net. No. Depends on the criticality of the net. That time you use 30 cross 20 or sometimes 20 cross 20.
Okay, I will read this.
When we have the 30 cross 20, that time it is in rectangular. When
Okay,
we are using 20 cross 20, that time it is square.
okay, I will read this contact.
Okay. For PMOS device, why we give negative voltage to the gate?
Okay, so PMOS device is good for low voltage. So we will go for negative only.
No, I
Low
want clear
voltage.
explanation.
Hmm?
I want clear explanation with a diagram.
Okay, so like PMOS working on low voltage and NMOS is working with high voltage. So due to that, it's PMOS is good for passing low voltage. So like if we no okay
No, you can note down.
okay PMOS
Why we give negative voltage to the gate?
negative okay Fine.
Yeah, that's all.
Oh, okay. Thanks. Thank you so much. Seriously.
They will provide. Is there?
What?
Sir is there in meeting or Ranjit?
I I don't know. Maybe on mute or you just leave.
Okay. They will provide any classes. Hi Ranjit, are you there?
Whatever they provide me, that are not working with me actually. Just they're just providing
What they
some
provide
videos.
you? Videos?
Just videos, some from YouTube. And seriously, I studied means for basic I cleared means whatever theory I mostly I feel I answered well actually. So theory I don't
Okay.
have problem. I just problem with like some this question like they will ask and I like to start figuring out okay what I have to answer actually. And the problem is I giving 8 9 interviews actually and still it's not working for me is for some I don't know I feel if I feel like okay for money they will not hiring me so I ask for less money so sometimes that also not working with me they are means hiring for
Less means less
less
salary
money.
you are asking?
Yeah, less early but they didn't say me like that okay they did negotiate actually they just hired any other candidate even without negotiating me. So for some interviews gone by that, and like I'm totally going demotivated. So I'm not sharing my resume even ki, okay an interview will gonna happen. So I'm feeling seriously bad actually, and
That's okay, you will
almost
get good.
yeah. Let's see.
Mhm.
Okay.